Blender 5.2 might be one of the biggest updates we've seen in years. The new experimental physics system completely rethinks how simulations work in Blender, introducing a modern framework that's more flexible, more accurate, and built for the future. Let's break down what's actually changing. Starting with cloth dynamics, Blender now introduces a unified cloth dynamics modifier and node group that can be applied to almost any mesh, instantly giving it realistic cloth behavior. The system now includes vertex pinning, controls for stretchiness and bendiness, and even support for mesh tearing. Instead of manually animating every fold and wrinkle, Blender simulates how fabric moves based on physics. It also allows cloth to tear automatically when the stress on the material exceeds the limits you define, removing the need for complex workarounds or manually swapping damaged meshes during an animation. Since this is a brand new experimental system, it's still missing a couple of things veteran Blender users will notice. Those are expected to be added in future updates. Next up is hair dynamics, and this section is a massive relief for anyone who has struggled with Blender's old particle hair physics. The new system simulates strands of hair, fur, ropes, feathers, or any long, flexible geometry. But instead of being tied to a legacy particle system, this new simulation runs directly on Blender's modern curves framework. This means your hair strands respond flawlessly to gravity, rapid motion, wind, and collisions. If a character spins around, the hair swings out with realistic inertia and settles naturally without the explosive glitched clipping we used to get. One of the biggest advantages of this unified engine is that hair and cloth now live in the same simulation space. That means Blender can finally simulate real interactions between a character's hair and clothing natively, something the community has been requesting for years, all powered by a single solver that keeps everything working together smoothly. At the core of Blender 5.2's new physics architecture is the completely redesigned effector system. Unlike previous versions where external forces existed as separate objects that Blender had to evaluate individually, the new system introduces a unified workflow built around bundles. A bundle is a structured data packet carrying the simulated geometry, its active constraints, and any external influences, passing them into the solver as a single, consolidated input. Effectors are the components responsible for injecting these external influences into the simulation environment. This system includes three primary types of effectors. Number one is colliders. They allow any closed mesh to function as a collision surface, with the solver reading its geometry directly to generate accurate contact constraints. Number two is custom forces. Instead of relying on traditional preset force fields, they use geometry nodes to calculate a unique force vector for every point on every frame. This makes it possible to drive simulations using procedural noise, distance fields, animated attributes, or virtually any custom logic. The third type is custom effectors. Built for advanced users, they make it possible to add custom behavior directly into the physics solve. All of these effectors can be combined into a single bundle and attached to any object, creating a far more modular and powerful system for building complex simulation setups. To control how effectors influence a simulation, Blender introduces a new filter system. Instead of every force affecting every object, filters let you decide exactly which simulations respond to a specific effector using simple tags. The foundational engine driving this entire simulation overhaul is the new XPBD Solver, which stands for Extended Position-Based Dynamics. This modern simulation solver is designed to make cloth, hair, and soft body physics more stable, more accurate, and far easier to work with. Unlike legacy force-based engines that frequently glitch or explode under fast motion, an XPBD solver resolves physics by prioritizing positions and geometric rules first. While Blender 5.2 introduces a powerful native XPBD framework, the production ecosystem is simultaneously expanding through advanced third-party add-ons and external solvers. It is critical to distinguish these specialized tools from Blender's built-in systems as they serve different production requirements. The first one we have is the ZOZO Contact Solver, an open-source cloth simulation engine developed by Japan's largest fashion company, ZOZO, available through an official Blender add-on. It uses the finite element method to prevent cloth from stretching unrealistically or intersecting itself, resulting in highly accurate and stable simulations. The second add-on we have is HiPhyEngine, a high-performance multi-physics simulation engine designed to bring production-grade dynamics directly into Blender. It uses the massive parallel processing power of modern GPUs to simulate complex interactions such as granular materials, rigid bodies, and soft tissues at a scale that traditional native solvers often struggle to handle. This makes it an excellent choice for artists and studios that need highly accurate, large-scale physics simulations. Blender 5.2 is just the beginning of a new era for physics in Blender. As these experimental features mature, they're set to transform animation and simulation workflows. Thanks for watching, and see you in the next one.